Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. I will continue the topic simple molecules and covalent bonds. So here's the summary of the last lesson. Covalent bond is formed due to sharing of electrons between two or more nonmetals. Atoms form bond to achieve full outermost shell, that is inert gas electron configuration. Covalent bond is formed between either atoms of the same nonmetals or different nonmetals. So here's the learning outcome for this lesson. Describe the formation of covalent bonds in simple molecules, including H2, Cl2, H2O, CH4, NH3, HCl, CH3OH, C2H4, O2, CO2, and N2. Use dot and cross diagrams to show the electronic configurations in these and similar molecules. Here is the periodic table. First of all, I'm going to draw the staircase line so you have better idea of about the position of metals and non-metals. So in this area, we are having only non-metals. This is above staircase line. In this area, we are having only metals. Remember, this last group is inert gas. This group is inert gas or noble gas. Does not take part in bonding because they neither share electrons nor lose or gain electrons. This topic we are concerned with the non-metals only. This is some examples of the covalent bond or covalent molecules formed from atoms of the same element. I gave you some examples in the last video. H2, O3, N2, F2, etc. You see, they all have atom of the same elements. Those atoms of the hydrogen, atoms of hydrogen. And in this one, you are having atoms of oxygen. In the same way, in N, you are having atoms of nitrogen. And in F2, you are having atoms of fluorine. We'll see some examples of covalent molecules formed from different elements. H2O, you have atoms of hydrogen and oxygen. In the same way, you are having other examples like NH3, where you are having atoms of nitrogen and hydrogen, HF, atoms of and H. This HF, you are having atoms of H and F. CH3OH, C2H4, SO2, etc. Many examples. Now, before proceeding, I want to recall the concept of valency. It's very important to know the concept of valency because this will help you in predicting the chemical formula between atoms of different elements. Valency is the combining power of atom. Valency is the combining power of an atom. It helps in predicting the formula. Fine. So for different groups, there are different valencies. For example, for metals, these are the valency for metals. We know these are metals. 1, 2, 3. Here's +1, +2, plus 3. For non-metals, 4, 5, 6, 7. 4, we have 4 valency, we have plus minus 4. Here we are having minus 3. Group 5, group 6, we have minus 2. Group 7 is minus 1. No valency for group 8, as I told you that they do not take part any in the formation of bonding. See one thing, that for metals, the valency is equal to the group number. The group number indicates the number of valence electrons, which means these are the electrons which metals are going to lose. So these become their valency. So it's easy to predict the valency for metals, group 1 till 3. But what's happening from group 4 till group 7? The valency will be equal to the number of electrons they are going to gain. Like, leave group 4, they have plus minus 4. The reason is that they contain both non-metals and metals. So some are losing 4 electrons, some gain 4 electrons. For group 5, they gain 3 electrons. They need 3 electrons to complete their valence shell. That's why the valency becomes 3. Also, the sign is minus, which indicates they are going to gain electrons. For group 6, it's minus 2, which indicates that they are going to gain 2 electrons. Group 7, they're going to gain 1 electron. That's why it's minus 1. Now let's do some working. Let's predict the formula between oxygen and chlorine. Oxygen, the symbol for oxygen is O, and chlorine is Cl. Oxygen belongs to group 6. Here's oxygen. Here's oxygen. And here's chlorine. So let's write the valency for oxygen, group 6. Valency will be minus 2. Chlorine, group 7, minus 1. Ignore their charges, and these number becomes their subscripts. These subscripts will be exchanged. The final formula will be OCl2 or Cl2O. Name is dichlorine oxide. Dichlorine oxide. You can even call it oxygen dichloride. Oxygen dichloride. Di means 2. There are 2 atoms of chlorine involved in this. That's why I'm writing di. Now let's work out the formula between carbon and fluorine. Carbon belongs to group 4, so valency will be plus minus 4. Fluorine belongs to group 7, the valency will be minus 1. Ignore their charges. Now these subscripts will be exchanged. So there will be 1 carbon and 4 fluorine atoms. So we have CF4. We call it carbon tetrafluoride. Tetra means 4. Tetra means 4. We write here mono means 1, di means 2, tri means 3. Just for your knowledge. That's all for today. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.